J-HAT 塾
Please hit subscribe.
For this problem, we are asked to graph this function. This is a parabola. And then we are asked to give the maximum and the minimum values and also to find the value of x at the maximum. So there are 4 problems. All of them are using the same parabola, but the interval that is being looked at is different for each of the problems. So the first problem does not give an interval, and so the interval that we can consider would be the entire domain of this parabola. And the domain of a parabola is the entire number line. And so we say negative infinity to infinity. That's the open interval for the entire number line. The second problem says that we are going to be looking at the interval where x is greater than or equal to 1/2. That is equivalent to saying the closed interval from 1/2, or rather half open interval from 1/2 to infinity. The third problem says we're looking at the interval where x is greater than 1/2, and this is equivalent to saying the absolute value rather is greater than 1/2. The absolute value of x is the distance from the center, from 0. So that is the distance from 0 to x. And this interval says that that distance must be greater than 1/2. And those values would be when x is to the left of minus 1/2, because if you think about 0 minus x, that's definitely going to be greater than 1/2 if x is to the left of minus 1/2. Also, we can consider the values that are to the right of positive 1/2. Again, the distance from those values to 0 would again be greater than 1/2. And so any x that falls under either of these intervals are valid, and so we can also write that this way. That's the union of the interval from negative infinity to minus 1/2 and 1/2 to positive infinity. And lastly, the interval, this interval here, which is the half open interval that does not include 1 and includes 5/2. So these are the 4 intervals that we'll be looking at. We will have the same graph for the parabola, but we will have different regions. We will have to be looking at different regions of the parabola for each of the problems. To obtain a graph of this function, let us first find the vertex of this parabola, where it is opening, the Y-intercepts, and the X-intercepts. First, the vertex is easily found from this standard form of the parabola. That is just this. So the x coordinate of the vertex is 1/2, and the y coordinate of the vertex is 10. And because we have a negative here as the coefficient of our x squared term, then this parabola is opening downwards. To find the y-intercept, we just set x to 0 because this is the point where the graph crosses the y-axis. And at the y-axis, the x is 0. So we just set x to 0. So we put 0 here. So this here becomes 0. And there we obtain 39/4 as the y-intercept. For the x-intercept, that is, those are the points where the graph of the function crosses the y-axis. And at the y-axis, or rather the x-axis, and at the x-axis, the value of the y, or of f of x, is 0. So we set this whole thing to 0, so that 0 equals this. And then we find x, and those will be our x-intercepts. And we just move the 10 to the other side, and we cancel the negative signs. Then we can just get the square root of both sides. We get this. And then we just move the 1/2 to the other side. We obtain this. And we notice that square root of 10 is actually greater than square root of 9. And square root of 9 is 3. So these x-intercepts are located just above 3 and just before negative 3. Here we just graph the entire function for the 4 conditions that were given. So the first condition is, so we color coded it here. The first problem, the first condition would be red, second blue, third yellow, and the last would be green. In this graph, for the first problem, we are told that the parabola, we are not told of the interval in the parabola to look at. So we should assume that we are looking at the entire domain of the parabola, and the domain of the parabola is actually negative infinity to infinity. That's the entire number line. And so if we just graph that, we will see that the vertex is here. So that's 1/2 10 as we found in the previous slide. And the y-intercept is here. Again, from the previous slide, that's 39/4. As for the x-intercepts, we found that it's minus 10 plus 1/2 and plus 10, or rather minus square root of 10 plus 1/2 and plus square root of 10 plus 1/2. And minus square root of 10 plus 1/2 is just a little bit greater than -3. So this is to the right of -3. -3 would be around here, and this is our x-intercept. For this other x-intercept, this is a little bit greater than 3, less than 4. So 3 would be to the left of this. So 3 would be around here, and this is our x-intercept. And so we can graph the function. And we notice that we have the same function for all 4 problems. What varies is actually the interval in which the function is defined. So for the first problem, the function is defined in the entire number line, and so we can look at the entire parabola. That's the red one. And so if we're looking for the maximum, we know that's going to be at the vertex. So here at the vertex, the maximum is 10, and the x is 1/2. However, this parabola continuously, or rather extends to infinity, negative infinity without bound. And so there is actually no minimum here for the entire parabola. Now, if we look at the second interval, it says 1/2 infinity. So it's a half open interval. And so 1/2 is included in the interval, and that's going to be the blue graph. So you see that this is a closed endpoint here. And then we have a blue graph going down and all that. And so it actually includes the vertex. So we have a maximum again at the vertex. So we get 10 here, because this is the maximum value of that blue graph. And again, at that maximum value, that's still the vertex. So we get 1/2 in here. But because this extends infinitely downwards, so we again do not have a minimum for this interval. Now for the third interval, we are told that that is this interval, which means that it must be less than -1/2 in here and must be greater than 1/2. So we see the yellow graph, we have a hollow endpoint here, and it extends downwards here. And here we also have a hollow endpoint at the vertex, and it extends downwards. And because we have a hollow vertex here, and we can see that actually if the vertex were included, this would have been the maximum. But because it's not included in the interval, we don't really have a maximum in this case. There is no biggest point in the given interval, and so we don't have a maximum, and we don't have an x at that maximum. And because the parabola and the interval given actually extends downwards and infinitely downwards, so again there is no minimum. And for the last interval, that's for the green interval here, it's between 1 and 5/2. And so we estimate 1 to be between 1/2, so just a little bit above 1/2, so it's going to be here, and less than 5/2. So 5/2 is less than 3, so it's going to be a little bit to the left of this x-intercept. That's why we have it here. So the 1 here is hollow because it's not included in the interval. The 5/2 is included in the interval, so we have a closed circle here, solid endpoint. And because this is hollow, this would have been the maximum if it were closed. Because this is hollow though, we don't have a maximum for this interval, this green part of the parabola, and so we don't have a maximum, we don't have an x for that maximum. However, we do have a minimum because The interval ends here at 5/2, and clearly this is the lowest point in this interval. So we just have to compute the value of f of x at this point at 5/2. So we substitute 5/2 here in the function, and that's 5/2 minus 1/2 squared. So that's 5/2 minus 1/2 is 4/2, or 2. 2 squared is 4. So we get minus 4 plus 10, which is 6. And so our minimum value for this interval here is at 5/2, x equals 5/2, and that's 6.
If you learned something new today, please help my channel by clicking the subscribe button and the bell for the notifications. See ya!